Hello students, today I will be teaching about the secondary development in the stem of dicots. So it is a very important topic for the NEET examinations and other regional entrance examination because there are multiple questions that has been asked from this topic. So it is very important to clear your concept from this topic, and it is sometimes becomes an ambiguous topic for some students. So I will be making it for you easy, and there will be no confusion, no bafflement for these questions. And let's begin with the secondary development in the stem of a dicot plant. So I will be teaching you with the diagrammatic representation because here I will be labeling all the layers or TS sections of the stems, because if you do not know the labeling and the regions which is growing, which is breaking down, which layer is forming, so you can't understand it properly without the diagrammatic representation of this topic. So it is very important for you to note all the diagrammatic representation, not a very classy diagram. I will be making very rough diagram so that you can understand. Just I am not making it for the competition like any drawing competition, just it is a representation to understand the concepts. So let's begin, because my diagrammatic representations are very poor and I'm very bad at drawing. So I'm telling to you before. So let's begin with the uh, secondary growth. Secondary growth in dicot stem. Now I'll be making the stem, all the layers. This one is epidermis. It is the outermost layer of a stem. Epidermis of stem is cutinized. Cutinized, that means it has a cuticle that reduces the transpiration. Cuticle, the sole purpose of this cuticle is in reduction of transpiration process. Transpiration process is reduced due to the presence of this cuticle. So, and one thing you need to keep in your mind is that epidermis is made up of parenchyma tissue. Parenchyma tissue, you have to keep it in your mind, very important. Parenchyma tissue, and inculcate in your mind that epidermis is made up of parenchyma tissue. And this one is the endodermis. Endodermis is the innermost layer of the cortex. I will be making the cortex very precise way, but firstly I am mentioning the endodermis. Endodermis is the innermost layer of the cortex, and it has starch sheath. That means it is a in Hindi we can call chadar. It is chadar like sheath. Starch is present in this endodermis like a sheath. And this one is the cortex region. It has three. Usually the cortex is divided into three region: hypodermis, general cortex, and the endodermis. Endodermis is the innermost layer, general cortex is the middle layer, and hypodermis is the outermost layer of the cortex. So I will be making the hypodermis here. It is multi-layered. Hypodermis is multi-layered. You have to keep in your mind that hypodermis is the multi-layer, and hypodermis is the property of the stem only. It is not found in the root. Hypodermis is not found in the root because cortex is not differentiated into hypodermis and other part. In root, cortex is only differentiated into cortical layer and endodermis, not hypodermis. Let me finish with this diagram first, and then I will be explaining all the things here. This one is hypodermis. Hypodermis, part of cortex. Hypodermis is made up of collenchyma tissue. Collenchyma tissue. Hypodermis of dicot plant is made of collenchyma tissue. Dicot stem. Let me write it down here because some student will get confused. Hypodermis is made of collenchyma tissue, and this one is the cortex. This one is cortex layer. It has some intracellular spaces, that's why I am making like this. It is cortex. You can say it cortical layer, cortical tissue or cortical layer. Cortical tissue, I will be writing here cortical tissue. Cortical tissue is made up of parenchyma tissue. These are the questions of NEET examination. Generally this is asked, cortical tissue is made up of what kind of tissue? Cortical tissue is made up of parenchyma tissue. Is it have a intracellular space? Yes, it has some intracellular spaces. You can see this spaces, intracellular spaces are present in the cortical layer. And the last one of the last layer of the cortex is the endodermis. Endodermis has a starch layer, so I have written down here that the starch layer is present, a starch sheath. And this one is the medulla. You can remember that the kidney has outer cortex and the medulla is the innermost part. In the same way, here is the medulla is the innermost part of this dicot stem. Medulla is also called pith or medulla. And here is the pericycle layer. This pericycle is made up of sclerenchyma tissue, and it is found in semilunar patches. Just inculcate in your mind that pericycle is made of sclerenchyma tissue and found in the semilunar patches. And this one is the medulla. Medulla is made up of parenchyma tissue. Because everything will be clear, so I am writing all the tissues name. Parenchyma tissue. And here is the presence of vascular bundle. What is vascular bundle? Vascular bundle is the combination of xylem and phloem. Usually phloem located on the peripheral region, and the xylem is located in the central region. Central, that means towards the medulla or pith. And there will be presence of a cambium. Cambium is also called intravascular cambium. Here it is called intravascular cambium. There will be presence of usually four vascular bundle. 4 vascular bundles are present in the centralmost part, in which phloem towards the periphery and the xylem towards the central path. And I think you all are familiar with this diagrammatic representation. Now you have a general idea about the anatomy of the stems. Now you can understand the process, how the histological pathway occurs during the formation of the secondary growth. Now during the secondary growth, what happens here, that this cambium which is present in between the xylem and phloem, these become meristematic again, and here are presence of medullary rays. And these medullary rays are the product of differentiation. These again de-differentiated and become meristematic to form interfascicular cambium. So this interfascicular cambium and the cambium which is present in between the xylem and phloem, which is called intrafascicular cambium plus of interfascicular cambium combines to form the ring-like structure which has the capacity to divide, and it divide the inner it divides on outer part and inner part also, but the dividing capacity on the inner part is more than the outer part. That's why what happens, this ring, it is a ring like structure which is present in the xylem and phloem region. Here this one is the what, this is the phloem and this is the xylem, this is the phloem, this is the xylem, this is the phloem and this is the xylem, this is the phloem and this is the xylem. What will happen, this ring, vascular cambium ring, vascular cambium ring, what will happen, this ring has the capacity to divide on the outer side also and the inner side, but the dividing capacity on the inner side is more than the outer side. So it will, what will happen, it will divide the cortical layers. Cortical layer will be broken down due to the activity of this cambium ring, and eventually there will be formation of secondary xylem and secondary phloem. But it is mentioned in your book, and it is fact that the secondary phloem and the primary phloem usually broken down, and it usually get crushed due to the continuous activity of the cambium ring and the formation of the secondary xylem. If there will be more formation of the secondary xylem, then what will happen, this grows outward and these cells are degenerated, these cells will become crushed and vanishes, and but the primary xylem remains intact toward the center, primary xylem remains intact toward the center. This xylem, there will be, for due to these, this cambium ring will differentiate into, this vascular cambium ring has the capacity to divide, capacity to divide. What will happen, this ring will form secondary xylem and secondary phloem. These secondary xylem and secondary phloem, secondary phloem may get crushed due to the activity of the secondary phloem, because it has more capacity to divide on the inner side, so there will be more formation of the secondary xylem, and these will differentiate into, these vascular cambium ring differentiate into the secondary xylem. Secondary xylem and secondary phloem, these are the product of redifferentiation, these are the product of redifferentiation. Vascular cambium and cork cambium are the product of dedifferentiation, and secondary phloem, secondary xylem, these are the product of redifferentiation. This is happening, this process is happening toward the central part, intrastellar region, but outside this, in this cortical region, what will happen, there will be formation of another ring, this is, that's called cork cambium. Cork cambium is also known as phallogen. I will not be teaching the whole process of this formation, but now I am just giving you a brief idea about the formation of this cork cambium, how this works, how the cork cambium works here. There will be formation of the cork cambium inside this cortical layer. This cortical layer, this cork cambium is also known as phallogen. What will happen, this also has the capacity to divide on the outer side and the inner side also, so it will divide on the outer side and the inner side. Outer side, it will cut down some of the cells, and there will be formation of the phallem. Phallem is also known as cortex, and the inner side there will be formation of the secondary medullary rays, secondary cortex is also known as phelloderm. Now I am teaching you to, let's wait, let's see what is happening here. Cork cambium is present, outer is phellem or cork, it replaces the cork, replaces the epidermis, and inner is secondary cortex, it is called phelloderm. And this cork cambium is also known as phallogen. It is for this outer region part, because due to the formation of the secondary xylem and secondary phloem, these layers has to be replaced. So to replace all this layer, there will be formation of the secondary cork cambium, which has the capacity to divide, and it will divide to form phellem, which is also called cork, and the inner side it will form secondary cortex, which is also called phelloderm. Phallogen, phelloderm, and phellem, these are commonly called together, these are commonly called periderm. And due to this cambium ring has the capacity to divide, but this is under the control of physiological control and environmental control. So throughout the year this does not occur constant, and the space of cutting is not smooth. So there will be formation of the early wood and late wood. Late wood is also known as winter wood, and early wood is also called spring wood, because in in the spring season the activity of the ring is more. So there will be formation of more xylem elements, and the wood formed during this season is less dense, their density will be less, light weighted wood will be present. And the in winter season there will be formation of the hard, there will be formation of the late wood. Late wood is dense, it is dark, because there are few xylem elements. And wood is also, the wood is generally secondary xylem, wood is generally secondary xylem, it is. And there are two kinds of wood, hardwood and sapwood. Hardwood is present in the greater part of the secondary xylem, and this uh, soft hardwood and softwood is present on the peripheral part. Softwood conduct water, hardwood doesn't conduct water, because the vessels are blocked by tyloses. So I will be winding up with this topic, because uh, due to the lack of time I have to wind up. But in general, uh, after watching this video you can read NCERT, and you will be making a general idea about how the process is going on, and what are the process happening inside this stem during the formation of the secondary growth, or the secondary xylem and secondary phloem.